My name is Kamaljit Singh and I'm an associate professor at the Institute of Geoenergy Engineering at Heriot-Watt University. I've been here for 6 years and I've used Teledyne ISCO pumps for my research. So my research group, which is DigiPorFlow, and we do very diverse research related to subsurface hydrogen storage and subsurface CO2 storage. We did a lot of work with oil and gas previously. And I've used Teledyne here, but also before that, my first exposure was when I was at Imperial College London, and we started using ISCO pump there. And the reason for ISCO pumps, they are precise and very robust. Because what we do a lot of experiments in the lab, and then we put the pumps on our van, like Zaid and I did when we went to Switzerland. And we moved through lots of rough and tough terrain, sometimes not going off-road, of course, but they have always behaved very well, so the precision haven't dropped, and they are very easy to use, user-friendly, and that's the thing I actually like using pumps. We got 4 pumps here, but in the geoenergy group we got many other pumps from ISCO.
One of the examples that where we used ISCO pumps quite a lot in our experiments was for these flow experiments, where if you can see the schematic, we have a core holder where we have the rock, which sits inside the micro-CT machine, which is the imaging equipment. And we have 4 ISCO pumps that are connected to that core holder. And all of them have different purposes. So one of them has hydrogen inside, which is one of our injection fluids. Then the other pump has brine inside, which is also one of our injection fluids. And there is another pump which controls the pressure on the rock sample. So that's the confining pressure pump. And then there is another 4th pump that is connected to the flow loop, and that pump receives all the fluid. So all the fluid that goes in and out of the rock at elevated temperature and pressure, all of it is controlled by these 4 ISCO pumps. So the good thing about these pumps is that with a single controller, you can control multiple pumps, and then also you can record whatever the readings that go out from those. So this is a good example of how we use multiple pumps together to control our flow experiments. And with that, we are able to image fluids inside the rocks, and we get very cool pictures like that, where you can exactly see where each fluid is sitting inside what part of the rock. And this gives us an idea how much fluid we can store in the rocks and how much we can take out from the rocks as well. So these syringe pumps are an integral part of our experimental system that we usually incorporate there.
Okay, so hi, my name is Mohommed Mandhari. So I'm a first-year PhD student at Heriot-Watt. I'm a part of the DigiPorFlow group and the Geoenergy group within IGE and the Lyell Center, and I'm looking into hydrogen storage in carbonate rocks.
Hi, I'm CJ Jones. I'm part of the DigiPorFlow group in the Institute of Geoenergy Engineering and the Geoenergy group in the Lyell Center, second-year PhD here at Heriot-Watt.
Heriot-Watt in the Middle East is really well known throughout the history for their petroleum engineering degrees. And when it comes to subsurface expertise, they're pretty much, top 12 in the world? So pretty much for the Middle East, Heriot-Watt is the to-go choice.
I chose Heriot-Watt because of the sort of interdisciplinary nature of the research here. I come from quite a different background to most of my colleagues, and Heriot-Watt's been great at sort of facilitating the really niche research that I want to do.
So I'm looking into hydrogen storage in carbonate rocks, or carbonate reservoirs. So most of the research done is mostly related to sandstones, but in regions like the Middle East and Southeast China, most of the reservoirs are actually carbonates, and most of the actively producing petroleum reservoirs are carbonate rocks. So there's quite a lack of research there. So I am hoping to fill that gap.
So I'm looking more towards biogeochemistry and sort of chemical reactions like mediated by microbes that happen in the deep subsurface that might affect hydrogen storage in the subsurface. I'm also looking at multi-phase flow in these reservoir rocks to see how biofilm sort of presence, microbial activity might affect the way that hydrogen flows and interacts with other fluids in the subsurface.
There's a lot of unknowns, especially when it comes to, for example, in carbonate rocks, the way their pores are arranged are quite different compared to sandstones. And being able to image that and really understand what's going on there is a significant challenge.
So I suppose a significant challenge with me is working with living things, using apparatus and techniques that maybe weren't designed with that in mind. There's been a lot of adapting, lots of thinking about how microbes that live in the subsurface are going to behave in these kind of systems, how they're going to misbehave in these kind of systems. Lots of problem solving, lots of fun.
So the Teledyne ISCO pumps are quite heavily involved in my project. So quite a significant basis of my research is experimentalism. And all of those experiments are done using Teledyne ISCO pumps. So that's easily half of the project.
The Teledyne pumps are really quite useful in my experimental work, whether it be looking at biogeochemical reactions under high pressure and high temperature conditions using pressure vessels, taking samples from those, injecting gas into those systems, or whether it be with more complex systems like core flood setups. They're really handy, they're really good.
The experimental part of my research involves injecting hydrogen into a carbonate rock and then flooding it with brine and doing it across multiple cycles and imaging it throughout each cycle. And the precision that we require, for example, I would inject hydrogen at exactly 50 microliters per minute. And Teledyne allows me to achieve that precision. If I were to inject accidentally too fast, it would pretty much ruin the results due to hydrogen redistribution within the sample.
So to sort of look at biogeochemical activity in the subsurface, when we're thinking about underground hydrogen storage, we need to use vessels that can operate at high pressure and high temperature that's representative of where we actually want to put hydrogen, where the microbes are actually living. So we get a sort of representative look at the activity in the lab relative to what's happening in the ground. Pumps are super helpful with that, helping get things up to pressure, helping take pressurized samples that I can then take on and analyze just how much hydrogen's maybe be consumed by a process, maybe how much that's affected the growth of bacteria in my experiments. It's good for delicate processes like that. And as for core flood work, I'm also looking at multi-phase flow. That is the way fluids interact. That's brine you'd find in the subsurface. That's the hydrogen we want to inject, and the rock matrix of the sort of reservoir, and biofilms of swell and microbes. Lots going on, complicated processes, and for that we use our sort of array of 4 Teledyne ISCO pumps because there's different fluids we need to inject at different flow rates, working at high pressure, getting things in our sets up to pressure, and maintaining that. Being from a background where we don't really use this kind of equipment, it's been really easy to get the hang of, really user-friendly, easy to be taught, easy to teach others. I'd certainly use it again.
There is absolutely no doubt that I'll be using ISCO pumps again in the very near future. My experience with Teledyne has been nothing short of phenomenal. Whenever I needed tech support or whenever I had any issues with the pumps, their response time were lightning fast.